Good morning, good afternoon, good evening, ladies and gentlemen, and today we're going to be looking at factoring for simple trinomials. And in order to do that, we're going to look back at a term that we looked at last time, and then we looked at binomial distribution. Now, of course, you know me and my Pokemon Go examples. Now, in order for us to actually understand how to factor for simple trinomials, we have to understand where they come from. All right, so let's try to, do some binomial distribution in this example. So we want to catch them all. X has got to catch X has got to catch also C, B has to catch X, and B has to also catch C. So I'm going to use different colors for this as I'm going along. So I'm going to use the color red for my X's just so we know what we're looking at. So X squared, because you have X times X gives you X squared. Then you have X times C. I'm going to use the color blue for my C. Okay. I'm going to use the color red for my X. Now, once again, I'm going to be going here, and I have B times X. I'm going to use the color green for that, so plus B, and of course the red color for my X, and then B times C. We're going to go B first, so we're going to go with the green color here. So you're going to go B, and you're going to go with C. Now, why am I also using the same color for the plus symbols? And that's because the plus symbols are the signs that belong to these coefficients. So let's see what we have here. Well, the X squared, there is nothing else that has a squared, so we bring it down. There's nothing else, X squared. But when I look at the CX and the BX, they're both common. So I'm going to put them both together, and I'm going to put them both in a bracket. And of course, BC is very lonely. It's British Columbia, so we're going to leave him alone. Now, we're going to use common distribution, and we're going to use common factoring to find out something we can take out. Now, if you look at these two terms, they both have an X. And since they both have an X, we can take it out. So if I take out an X, I'd be left with C plus B plus BC. So in order to interpret this, we have to look at what the original quadratic equation look like. And the original quadratic equation has ax squared plus bx plus c. So when we compare these two, what are we going to notice? Well, we're noticing here that my a value, which is the number that's beside my x squared, there's nothing written there. Now, if there's nothing written there, then we say that is the same as saying number 1. There's a 1 beside the x squared. This is also why we call it a simple trinomial. It's a simple trinomial because it's 3 terms. 1, 2, 3. And it's simple because the number beside x squared is a 1. Okay? Now, my b value, well, that is the number that is beside my x. Well, I only have an x right here. What's beside it? Well, c plus b. And of course, my c value is my b times c. So when we're looking at this, we're noticing that C is made up of the product of B and C, and B is made up of the sum of B plus C. This is a very interesting rule. Let's see if this works with another example. Now let's look at this example here. We have x plus 2 multiplied by x plus 3. Now, of course, we could have done binomial distribution, caught our Pokemon, and we'll find out what the simple trinomial is. But let's try to use a rule we just figured out. And we figured out that in my quadratic equation, so I'm going to put this here on the side, in my quadratic equation, my a value is still going to be actually 1. So it's still going to be x squared. It should still be x squared. That doesn't happen. I also know that my c value, which is my constant, should be 2 multiplied by 3. Now it's positive 2 multiplied by positive 3 because we see positive signs beside it. So 2 times 3, that is positive 6. Now for my middle term, we found out that it should be 2 plus 3 and the x. So I should have an x and 2 plus 3. 2 plus 3 is 5. They're both positive, so this should be positive 5x. So that's what my final answer should be. All right? Now, if that's what my final answer should be, let's see whether that works if we did binomial distribution. So let's catch our Pokemon. Okay. Yes, I can hear people groaning right now, but this is catching the Pokemon joke now. So x times x, you're going to have x squared. X times 3, you're going to have 3x. 2 times x, you're going to have 2x. And finally, 2 times 3 is going to give you 6. You want to collect your like terms. There's nothing the same as x squared, so x squared just comes down. Plus, well, you have 3x and 2x. What's 3x plus 2x? 5x. And then finally, plus 6. These two perfectly match. So the rule works. We don't have to do binomial distribution. We don't have to collect Pokemon anymore. Yay! So let's see how we can use this to actually go backwards. So if I were actually to give you this formula, how can I find this? All right, now in this example, what we're going to be doing is we're going to be actually going backwards. And this is what we call factoring simple trinomials. Once again, it is a simple trinomial because the number beside my x is a 1. We know it's a 1 because there's nothing written beside the x. All right, so we learned on the first page after we did that distribution, we learned that 6 is the multiplication of b and c. It's the multiplication of two numbers. We also learned that the number 5 was the addition of those same two numbers. So how can I go about doing this? And you go about doing this using PSN. Now what PSN is basically product sum notation. And what that is, well, you have to ask yourself, so your first question here is, you have to ask yourself, what numbers multiply to give us 6? So essentially what I'm asking you here is, what are the factors of 6? Well, the factors of 6, I'm going to write them here to the side. Well, I know I can do 1 times 6. I know I can do 2 times 3. Okay? Are there any other factors of 6? No. Now, 1 times 6 gives me 6? Yes. So this satisfies my first check. But if I did 1 plus 6, I'll get 7, which is not the number 5 I'm looking for. So this is not what I'm looking for. Now, 2 times 3 will give me 6, which is what I'm looking for, but 2 plus 3 will also give me the number 5, which is exactly what I'm looking for. So, in your second step, you're looking to find which of those pairs also add up to give us 5. Okay, I'm gonna put a question mark there. Let's be correct. So we found out 2 times 3 gives me 6, and 2 plus 3 gives me 5. So in your final step, you're just literally writing the form. And we know the form always looks like x plus b times x plus c. Well, I already know it's going to be x. It's going to be x. I also know that it's going to be a 2, and it's going to be a 3. It doesn't matter whether you put the 2 here or if you put it here, same thing. Are they going to be positive? Yes, because if I did plus 2 plus 3, that's going to give me 5. But if I did minus 2 plus 3, that's going to give me 1. So either way, it's going to be plus. Now, how do I know if I'm right? Well, you can check. How do I check? You do the distribution. So, catch my Pokemon. You're going to find that you're going to get the same thing you started with. So it works. Let's do one more quick example. All right, guys, let's take a look at this example. Now, once again, let's do our steps. We are now interested in which numbers multiply to give me negative 18. So I know that negative 2 multiplied by 9 is going to give me negative 18. I also know that negative 1 multiplied by 18 is also going to give me negative 18. I also know that negative 3 multiplied by 6 is also going to give me negative 18, and obviously vice versa. So obviously negative 9 multiplied by 2 will give me negative 18. Negative 18 times 1 is going to give me negative 18, and negative 6 multiplied by 3 will also give me negative 18. Now, this is a step here that you can skip in the future if you already know your factors. But until then, this is a nice thing to write down so you can have it in front of you. Now, I've written down all my factors. Now, let's take a look now at what will satisfy this clause. I want to get plus 7. Well, negative 2 plus 9. Well, I'm going to have negative 2 plus 9, which is 7. Hey, that worked right away. I'm great. Let's take a look at the rest just to make sure. Well, negative 1 plus 18 is 17. Nope, doesn't work. Negative 3 plus 6 is 3. Nope, doesn't work, and so on. Well, and negative 9 plus 2 is going to give me negative 7, which is not what I want. I want a plus. So we found our factors. And the second we found our factors, we simply go x, I know that I should have a minus 2, so minus 2, and a plus 9. And just like that, you have factored this simple trinomial. In the next video, we'll be taking a look at how to factor complex trinomials. Now, you guessed it, if simple trinomials is when there is a 1 beside the x, then complex trinomials is when you have anything else. So we'll take a look at that next video.